You've got to use the formula that's specific to the shape based on whatever the base is. Alright, so now that I'm done being long-winded, let's go ahead and figure this out. Alright, so area of the base, well, the base here they're telling us is 2 by 5. Alright, that means it's a rectangle of some type. So if it's a rectangle, length times width, 2 times 5 will give me 10. And that's going to be the area of the base. Now, the other component that's involved in the formula here is the height. The height is how tall the shape is. Well, that's what they tell us here at the end of that sentence. They tell us it's 3. So this is 10 times 3 here in the calculations. Didn't really have to do anything to find the height. It was just given to us. 10 times 3 is 30. And that's going to be centimeters cubed for the units. Now, follow-up question is, why is it centimeters cubed? Well, simple explanation. All right, when we're finding the volume of a square prism, sometimes called a cube, all right, well, when I'm finding the area of the base has a length and a width, and then that's the B part of the formula, and then we're going to multiply that by the height. Well, each of those things is measured in some unit, all right? Let's say it's centimeters, like this question. So I've got something in centimeters times something in centimeters times something in centimeters. Well, that's how I generate centimeters cubed. Now, if you're sitting there going, well, wait a minute, that doesn't make sense. Why does that make centimeters cubed? Well, let's put it back to numbers for a second. Let's say it was 2 times 2 times 2. If it was 2 times 2 times 2, all right, that would be the same as 2 cubed. All right, well, we do the same thing with the units that we do with the numbers there. All right, and so that's how we generate centimeters cubed or units cubed, whatever the unit is, inches cubed, feet cubed. It's all from that concept of a square prism, or otherwise called a cube. All right, let's keep going here. All right, B is the cylinder. Now, here you see that formula again that we just saw. But here's what's going to happen. All of a sudden, the book is going to start referring to the formula as pi r squared h. And you're going to say, hey, what gives? That's not the formula you just showed us. Well, actually, it is the formula I just showed you, because think about what B is. B is the area of the base. And in the cylinder, the base is this circular piece. So if I'm finding the area of the base, and the base is a circle, that means I'm really doing area of a circle. What's the area of a circle? Well, the area of a circle is pi r squared. So this B here is really pi r squared. Right? So even though it's written differently, it's actually the same thing. All right? And now you can also see why these two shapes are in the same section is because they're using the same formula. All right, so we've got to find the area of the base and then multiply that by the height. Well, as you can see, they're doing that there on the first line. All right, they did 4 squared, which is the radius squared. The radius is clearly labeled 4, no questions here, times pi. And notice they're writing that as 16 pi. So they're writing this with pi. That means they're writing an exact answer right now. Now, of course, you can change that to 3.14 if you want to. That's what the directions say, but they're going to stick with an exact answer for a minute. They're going to take that 16 pi and multiply it by the height, which is the other part of the formula, the height of the whole cylinder, which is 12. So I'm doing 16 pi times 12. 16 and 12 go together to make 192, stuck with pi. Your answer with pi, something we explored last week really for the first time, 192 times 3.14 is 602.9. All right, let's keep going here and take a look at the concluding part of example 1 here. Another prism. Now you're saying, well, wait a minute, why is that a prism? Well, remember what a prism is. A prism has rectangles as faces, right? And clearly we do see rectangles going around this shape here. All right, they maybe look a little bit squarish, but I assure you these are not squares. All right, and then those bases, there's a matching set, which is helpful. All right, can be any sided figure. So this is a triangular prism that you're looking at here. All right, so we're back to this B times H formula. All right, so I've got to find the area of the base and multiply it by the height. Now, this might be difficult for you to see just based on the way it's drawn here. So let me make this a little clearer and just draw the triangle piece. All right, the triangle piece right here, they show us that this line here measures 5, as in 5 feet. And there's a right angle marked there, and we'll explain that in a second. And there's no number down here. And that's what I really need. Why do I really need that? Well, remember, a triangle, the base and the height have to make a right angle. If this is my right angle, this is my height, because it's not one of the sides, which means the one it makes with the right angle with is the base. Well, we can see down here that that side that would match on the other side of the rectangle is 6. So if this is 6, this must be 6 as well. Right? And I need that because I have to find the area of the triangle, because that's B in our formula. All right, so remember what area of a triangle is. It's half times the base times the height. And now you're starting to go, whoa, wait a minute. The formula's got B and H in it. What gives? Well, there's actually two different meanings here for B and H. All right, and this is where this type of problem starts to get confusing. B and H here is referring to the base of the triangle and the height of the triangle. B and H here, well, B is referring to the area of the base, which happens to be this triangle, and H is the height of the entire three-dimensional shape. A lot to keep track of, all right? But we're finding the area of that base, so we're doing half times 6 times 5. These are the two numbers that get plugged in. 6 times 5 is 30. Half of that is 15. All right, and that's this answer here. All right, so now I know the area of the base. I'm going to multiply that by the height. Again, it's the height of the entire three-dimensional shape now. Well, the shape is standing up the right way, so the height here is going to be 7. So I'm taking 15 and multiplying it by 7. 15 times 7 is 105 feet cubed. All right, let's keep going here by looking at question number 2. In question number 2, it says a juice box is 3 by 2 by 4. And we're supposed to explain whether tripling the length, the width, or the height of the box would triple the amount of juice the box holds. All right, so the best way to do this, mathematically speaking, is to try it. All right. They're asking for a lot here, very true. They're asking for us to try it with tripling the length, and then tripling the width, and then tripling the height, and see if any of those triples the total volume. All right, so what you see on the left box there is me finding the volume of just the regular juice box, the 3 by 2 by 4 juice box. And as you can see, when we do that, we get 24. Okay, so that means we're looking for an answer of 72 now, because 72 means the amount of juice in the juice box is triple. If we get something else, then it's not triple. All right, so let's start off with the length. So I'm going to triple the length. Well, the length was 3. So if I triple it now, it's 9. But the other two numbers are the same. So I'm doing 9 times 2 times 4. When I do that, I got 72. Aha! All right, that's what I wanted to happen. I wanted the volume to triple. Remember I said that if I triple 24, it's 72. So yes, we know that tripling the length triples the amount of juice in the box. All right, well, what if I triple the width? Well, the width was 2, so that means now it would be 6, but the 3 and the 4 are still there. 3 times 6 times 4 is 72. Aha! It happened again. I tripled a different number, but I still tripled the amount of juice in the box. Right, then they triple the height. Well, the height is 4, so when I triple it there, it's now 12. So I'm doing 3 times 2 times 12. The other two numbers stay the same, and again, 72. So whether I triple the length or the width or the height doesn't matter. All right, the volume of the entire juice box still triples as well. The original box has a volume of 24 inches cubed. If you triple the volume to 72, you can do that by tripling just any one of the dimensions. Triple the length, triple the width, triple the height. You triple the amount of juice that that juice box holds. All right, let's go ahead and take a look at the next one here. The next one is another volume question, but instead of drawing the shape there, they're just giving you some words about the shape. And from that, you're going to extrapolate the information you need and solve. It says a drum company advertises a snare drum that is 4 inches high and 12 inches in diameter. And we are supposed to estimate the volume of the drum. Okay, so 2 pieces of information here. 4 inches high, well, remember, that's good because we need height of the entire shape. That's part of the calculation. And then the other thing we have here is 12 inches in diameter. And that doesn't necessarily help me directly. Let's talk about why for just a quick second. If you recall, the formula for finding the volume of a cylinder is pi r squared h, which is what you see right here on the screen. Well, notice d for diameter, that's not in there. Right? There is no d involved there. All right, so while having the diameter is a great piece of information, it doesn't necessarily help me so much in this particular question. However, what I can do, what I need to do, what I should do, is I should take that now and chop it in half. Because we know that half a diameter is the same as a radius. And that's the first thing they're accomplishing there right now, is they're taking that number and chopping it in half to get the radius, which they're now showing you as 6. Right? That piece of information does help me very directly here, because that's going to go in the formula for r. Here is my height. Pi is always 3.14, and then we can solve. So let's plug in some numbers and solve. 3.14 times the radius squared, which is 6 squared, times 4. 6 squared is the same as 36. So this is 3.14 times 36 times 4. Realize we did that first because of order of operations. Exponents have to get done first. And then I can just multiply. It's the same as 113.04 times 4, or 452.16. And since we're estimating, we don't have to worry too much about the decimals, so they just go with 452, as in 452 inches cubed being the volume of that snare drum. All right, let's go ahead and take a look at number 4. Now, number 4 is kind of a different type of question than what we've been doing, but it really is just taking the components and putting them together. They're asking us to find the volume of the barn. Well, realize what the barn is there. The barn is a composite figure. Composite figure is simply 2 geometric shapes put together. Right? This is 2 different types of prisms put together here. The top piece, the roof really, is a triangular prism. So we're going to have to find the volume of that guy using the appropriate formula. The bottom piece is a rectangular prism. So we're going to find the volume of that guy using the proper formula, and then we're going to put those 2 solutions together, and we'll have the volume of the entire barn. All right, so let's go ahead and go with that here. All right, finding the volume of the rectangular prism, the bottom piece. Now, let's refresh our memory really quick on one thing before we jump into that. Formula here, both prisms, B times H, the area of the base times the height. All right, so the base here, as they've drawn this, all right, is this bottom piece, what would in essence be the floor. All right, so to find the area of that piece, which is what capital B stands for, the area of the base, since it's a rectangle, I'm just doing 40 times 50, which is what they're showing you right here in the workpiece. All right, of course, 40 times 50, when you do the math there, that's going to work out to be 2,000. Then I have to multiply that by the height of the entire main structure of the building, I guess I'll call it, the bottom here. Well, the height of this prism, we've already used the 40 and the 50, so the height is 15. So I'm taking that now and multiplying it by 15, and when I do that, I end up with 30,000. Now, when we go to the triangular prism, realize here that the rectangles cannot be in the triangular prism the base. The base has to be the triangles. Or if it's a pentagonal prism, the pentagons. Or if it's a hexagonal prism, the hexagons. All right, the ones that aren't the rectangles. All right, here, because it's all rectangles, all right, just think of what it's sitting on. It'll work out great. All right, but here with the triangular prism, the triangles have to be the base. All right, so we're using the triangle formula then. Triangle, area of a triangle is half times its base times its height. And remember, those two guys right there, base and height, they have to make a right angle. And that's what this right angle mark is for on this triangle piece that you also see in your note-taking guide. Because those two guys, all right, have to be there to indicate that they're the base and the height. All right, so height is 10. And the base, well, that's going to be this length here. And even though there's no number there, it's the same as this number here, which is 40. So this is half of 10 times 40. Which is exactly what you see right here in the calculation. And then I'm going to multiply that by the height of that whole guy. Well, again, it's kind of laying down, so the height is actually going to be this way. And even though there's no number there, we see the 50 right there. So 50 for the height. Again, you're seeing that right there in the calculation. Multiply all that together, that's 10,000. Combine it with our 30,000 from the main structure there, and we end up with 40,000. So the volume is 40,000 feet cubed.